Hello everybody, today we are going to discuss about the Hubble constant. What is this Hubble constant and how does it behave in our universe? Now, we know that from Hubble, if we're in our universe like we are, when we are here, looking at galaxies across the universe, we see something strange. Light coming from far distant galaxies, although it travels on a line, it shifts to red. And if I look at other galaxies which are farther away from our planet, they also shift to red, but more. Now, what does this mean? In order to understand ourselves more clearly. If I have this star here, this galaxy has full of stars, and there's a star shooting out photons coming to our planet. What happens is, with time, the distance between these photons somehow increases. And this is something very strange. Why does this space behave like this? If I look at this galaxy, which is farther away, I see the same behavior. The ray of photons coming to us, it will reach us after some point, after some distance. But they will also see this effect. But this effect is slightly bigger. And far distant galaxies have the same kind of behavior. The photons coming to us, it happens something with them, the distance increases. So, in conclusion, Hubble tells us there is some sort of inflation. If this is a balloon, the universe, it inflates with time, increases the distance not only between us, we moving like this, and these galaxies, these stars, it increases the distance between everything about everything. Everything expands into something. We don't know what, but it expands. So with time, the distance between every photon increases from the other photons. Now this happens in the flat universe. Hubble is right, and it is like this. If we are in a flat universe, but we are not. There is a problem here. We are not in a flat universe. We are in a curved universe. And here, situation is slightly different. And we will see what Hubble wants to tell us by its constant. Yes, there is a constant somewhere. Something doesn't vary, but it's not what we think it is. Like I've said in my previous video, the universe is somehow a sphere. And it cannot expand because there is a wall here. But how do we explain that shift to red behavior of far distant galaxies? We should be able to explain it. Now, if you look over the internet, you will find a video called "Empty Space is Not Empty." I recommend you look at it, because in this video, you will see the behavior of space at subatomic level. I have explained how the universe was created by a series of big bangs, all happening at the same time, creating this movement at subatomic level. There are only tiny little explosions here continuously. This movement at subatomic level never stops. Now this movement is fundamental because this movement proves that ondulatory behavior of light. Think about it. If light it is a line, why does ondulate like that? Shouldn't stay as a line, always, and always travel in a straight line. But this behavior at subatomic level, created at the initial moment of the Big Bang, curves the light as it travels. That this happens because space itself behaves like this. And whatever photons travels through this universe, it is being curved by this behavior. And there is another problem. Because of this behavior, light trajectory also is slightly moved in a certain direction, not defined. What does this mean in our case? So, if I am here and I receive photons from far distant galaxies, I imagine that they travel in a straight line. But that happens only in a flat universe. In a curved universe, the situation is slightly different. On small distances like 1 second, 3,000 kilometers, 3,100 kilometers, there is a problem. I cannot see any shift in direction of light. If I would be able to measure on long distances, I would see shifting a little from linear trajectory. This is difficult to measure. In 1 second is difficult. But at hundreds of thousands of years, it's far more simple. What does this mean from our point of view? Well, it means like this. If I am a star here shooting photons, the trajectory of the photons are being curved in real time by this behavior of space. So in reality, the trajectory of light reaching our telescope after millions of years, it's this one. It is like this. It is a curve. I call it a perfect curve because it is being curved in all directions without any preferential direction whatsoever. Now, someone would ask, how do I know this hits our planet? But because this star shoots out millions and millions of photons in all directions. So for sure, some photons hit our planet after some time. Now, this trajectory, it's the trajectory of the first photon. But the second one has a different trajectory, only a little moved from the first one. The third photon also moved a little. So this curve moves. This other star has also a curved trajectory, but a little different. It's very, very different from the first one, but the mechanism is the same. If I look at the third star, which is very, 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 very far, I see it shifting to red even more. So this star has probably a trajectory of the photons like this. What does Hubble tells us is there is a constant between something and something else. That ratio is constant. But between what? My understanding is that what Hubble's constant is something like this. There is a constant between line 1 and curve 1. So this is a line 1 and this is a curve 1. If I make this ratio, what it means is with every second, the light is curved in the same manner. If I look at other galaxies, let's say I have this line 2 and this curve 2, I find the same number. And if I look at some other galaxies very, 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 very far away, the phenomenon is the same. This is line 3, this is the curve 3, and the ratio is the same. So, after all, Hubble is right with something. There is a constant here, but what is constant? It never varies. It's the behavior of space at subatomic level. This never varies. But galaxies in the universe move. This doesn't mean that the universe is expanding. You cannot expand something into nothing. That is impossible. The universe doesn't move. What it moves is space itself. And this movement at subatomic level, it's always the same. It doesn't change. It's not much faster or much slower. So if I give to light more time, if there is a galaxy here, if I give it more time, the curve will be curved even more, but with the same ratio. It will always be the same. And this is what Hubble wants to tell us. The conclusion that somehow the universe is expanding is not according with reality. What is real is the universe itself curves the trajectory of light on far distant galaxies looking at us. I'm talking about hundreds of thousands of years, if not millions of light years. It's difficult to replicate in laboratory, but this is a reality. Even light moves by a curve on long distances. A lot of people asked on Facebook, what curves light? And some people answer gravity. Yes, could be like this, gravity, but that is only around a star, between galaxies where there is nothing there. What curves the trajectory of light? What curves it is the behavior of subatomic level of space. That curves the light. You don't see it on small distances, but you can see it everywhere in the universe on long distances. This is the behavior of the curved universe, and we are inside. Hubble would be right if we would be outside, where space is flat. Hubble is right only here, but we are inside, and here the situation is slightly different. This is what I wanted to say, and I'm pretty sure the situation is like this. If you think you can replicate this, you will see that I am right. What happens is the universe only curves onto itself, and it curves even light. That is why there are no lines in this universe, and you cannot measure by a line. How should I explain this even more simple? Think about it. Everywhere you look on this planet, the Earth is flat. Within this room, the Earth is flat, but only for 1 meter or 2 meters, something very small. At a greater distance, we see that the Earth is curved. If we move farther away, we see the Earth, it is a sphere. So on long distances, we can see the curved trajectory. But on small distances, we won't do any kind of mistake. We will say space and Earth are flat, but only here, on small distances. We won't be far from the truth, but it's just an approximation. With light, at universal scale, it's the same. Right now, in this room, light, it is a line. But between galaxies, between clusters of galaxies, light cannot travel within a line. It is impossible. Space will curve it. That is the difference. So when we are approximating things regarding light, we are approximating linear trajectory, but that only works around our solar system and our planet and our laboratory. If we would do this experiment between one galaxy here and one galaxy here, you would see that I'm right. Space itself behaves differently at global scale. And this is what I want you to say. That Hubble is right with one thing, but it doesn't mean the universe is expanding. That is just impossible. The universe is not expanding. The universe is standing still. It's not going anywhere. That would be just impossible. What happens, it just curves indefinitely onto its own. And that is why I say it once again, we have no lines in this universe. This is my understanding about the Hubble constant, and I'm pretty sure I am right. If you think that I'm somehow wrong, I dare you to hit it and prove things are not the way I say they are. I think I am right, and I hope you will answer to my call. Thank you for watching.